All right, and we are back. We have Rafael Winterhalter online with us, and he's going to share his knowledge about building Java agents. Rafael is very knowledgeable about the topic. He created a Byte Buddy library and received. How many awards did you receive for that, Rafael? Plenty, I guess. Right, it was the Duke's Choice Award. It was the Groundbreakers Award. And well, the floor is yours. I'm going to be here next to you in case you need me, and I will be monitoring the session. And I'm going to ask the attendees to ask the questions from Rafael. He knows about the subject and he can give quality answers. So, Rafael.
Are you talking to me? Can you hear me? Sorry, I can't hear you. I have no clue what's happening in case I'm talking over you. Sorry.
All right, you can start. You can start. I'm saying you can start. You can start.
Okay, I can start and everybody can hear me, so I just can't hear you. Brilliant, because that's not important as much. Thanks for the introduction. I'm sure it was very charming and nice. Thank you so much for attending this talk on Java agents. My name is Rafael. I'm a software consultant in Oslo, and I work with Java agents quite a bit. So what I'm trying to do here today is that I'm trying to give you an overview of what Java agents are. Some people are, of course, not aware of it. It's a fairly obscure mechanism for many, but I'm trying to show you today that it's actually fairly useful, that it's something that you can use in your everyday life. And I'm trying to show you also how you probably already use Java agents. I'm working on Byte Buddy, which is a tool partially for the development of Java agents. And I'm also working on the Mokito library, which in the inline mock maker format also heavily relies on Java agent. And besides that, I've built some commercial agents for tool vendors and so forth. So I'm trying to give you an overview of that. And we'll see how far we get. My normal talk length is 60 minutes. 40 is short compared. So, but the points I'm going to go through is, first of all, agent instrumentals. What are agents? Then we look into some instrumentation, how you can change code at runtime. Then if we have time, we look a bit at class loading, and the rest of the time we spend on MS topics. And if you have questions on the way, just ask. I'm looking in the chat. Since since I can't hear you as a fourth, I'm a Linux user by heart, so I have to pay the price by not always having audio or video meetings, which isn't the worst thing that can happen to you in life, but it's inconvenient at these kind of formats, right? So first of all, so what's a Java agent? Important question. If you just take this out of my presentation, you've learned something, hopefully. But what Java agents are basically is alternative entry points into a JVM process. So you all know public static void main. That's the standard way of starting and running a Java application. And the main method is just a symbol. So that's a conventional name that is used to enter a Java code base. And a Java agent is not more than that. It is a so-called pre-main method. And as the name suggests, the pre-main method runs before the main method. And in the manifest, instead of writing main class and pointing to the class that defines this conventional method, a Java agent is just that, a jar file with a manifest where the manifest file points to another class, which is the pre-main class. And it's the same signature almost, only that it doesn't take a string of arguments, an array of strings. It just takes a single string. An agent can only have one. And you can have multiple of those. You can have more agents, and then they will just be executed on the main thread before the program starts. And basically, you can just write any code you want, and it will be executed before the actual program is triggered. And in the most trivial case, you can use that to, for example, set environment variables. Let's say you want to run something on Kubernetes, and Kubernetes initializes a bunch of system properties for you in the process because the Docker pre-built image you use does that, and you want to emulate it locally. Now you can. You just write agent that sets up the environment just as the Kubernetes cluster would. Additionally to these so-called static agents that run before a Java process, you can also run one in parallel. And that's actually a really cool feature that helps a lot when you implement tooling for the JVM. And the dynamic agent is just, again, a jar file with code and a manifest file, where instead of a pre-main agent, you have an agent main method. And the agent main method is not executed on the main thread, it's executed on the attached thread. And the brilliant thing about those agents are that they can be attached at any time. So even if a Java process has started, you can still inject code into the same JVM and make the JVM run code in parallel to the actual application. And just as a pre-main agent, you basically have to just find the PID, the process ID of the process you want to attach to, and you just inject your jar file in there. You can alter the program even if it's been running for years, technically. And again, you can have multiple of those, but there's only one attached thread. And if, for example, an agent never returns, then the option is blown. Then you can never again attach to the JVM. But typically, agents run shortly and then rather spawn their own threads. So typically, you can attach multiple agents there. And a lot of tooling that you might use, like I've been working on Instana, which is a APM tool. They make the opportunity they use the opportunity to, for example, discover running JVMs and then just hook into all of them to enhance the behavior and to monitor them. Because you can, in the simplest case, just trigger JMX and extract metrics of a JVM process. In the more complex cases, you can basically rearrange the entire JVM. Yes. So how does that work in practice? A static agent, you just specify. As you specify the class path, you just specify the -Java agent property, and you can't specify more than one file on the Java agent option. You have to, but you can have multiple -Java agents. And additionally, to the path to the jar file, which has to be on the local file system, you have to point, or you can optionally point to an argument, and it's a single argument that will be passed to the pre-main method down here. Right. The dynamic agent doesn't have to be specified on startup, right? As I mentioned. Instead, you have an API in the JVM, which is called the virtual machine API, and it's in the tools jar up till Java 8, since Java 9 is in the JDK attach module of the JDK. And that API allows you to just point a Java agent to any PID and then attach to it. So basically, you find PID B from your other Java process that runs as PID A, and then you can inject every jar file into the other process, which sounds very unsafe, but it's not really, because the JVM checks if this process comes from, like if the spawning process is the same user as the attaching process and only allows it by restricting access to the same user. Because if you're an attacker and you have already gained privileges to the user running a certain process, then you already lost your defense measures. A user has, of course, control over its own processes, so this is possible. And it's important, if you want to run like a generic tool that attaches to any process, it has to be of a superior user level, and then you have to rather switch to that user for just the attachment and then switch back to your normal user. But then you can just spawn on any computer to any JVMs you can access in the way that Linux would allow it. And on Windows, of course, there's no security, as we know. But there's somewhat security, but it's not as tight as it is on Linux. But on server machines, typically, you don't have to worry about those. Right. So what's really cool about Java agents, though, is not the ability to run in parallel or before an existing process. It is the ability to get hold of an instance of instrumentation, which is the second optional argument to any Java agent, pre-main or agent main method. So if you specify a type instrumentation and an argument of it, then this instance will be injected by the Java agent mechanism, and it will allow you to transform classes when they are loaded. And that means in practice that whenever the JVM loads a class, so let's say you have your controller bean that returns some values from a method, and then you install this agent, then you will be notified that this transformer bean is loaded into the JVM for the first time. then you get an opportunity to rewrite this class. So if the controller that you would have loaded would return some hard-coded cryptographic production key that is fixed for security purposes, then the Java agent could change its behavior in the test environment, for example. But of course, more practically, let's say you are a tool vendor, you want to measure how many calls you make to a database, and you want to basically collect these metrics. What you can do then is you just check if there's a JDBC driver being loaded, and then you rewrite this JDBC driver to do whatever it already does. Plus, whenever the method is called, you record the time, and whenever the method exits, you again record the time and you write this data to some Kafka topic or whatever. So this is where of course you can see this can come in fairly handy. And that's the reason why tooling is so awesome on the JVM. It's fairly easy to hook into existing processes and extract information, and it doesn't really require some invasive measure in your tool chain. You don't have to change your build systems and your deployment methods. You can just discover processes and hook into them. So at least it's possible. Not every tool does this, of course. But if you worked in the enterprise, you know how hard it can be sometimes to adjust these things. And then it is very, very handy to being able to just take existing processes and shove yourself in there. Right. Even further, you can retransform already loaded classes. Otherwise, the dynamic agent that's attached after the JVM startup wouldn't make that much sense anymore. Because if you attach, even after the program has been running for quite a while, you can still decide that now you want to insert yourself in this process and change these classes. Let's say you have a production server that has been running nicely for 1 year, and then after that year, it suddenly stops working, and you want to debug it, but you can't debug it without going into the process and basically extracting data. And it's not running in debug mode, of course, it's a production system, but you already took it offline. But if you kill it, you cannot do the forensics that you would need to do. You can do a heap dump, maybe you can do a thread dump. But with the Java agent, you could, for example, go into there and even fix a problem and put the server back online without shutting it down. And of course, if you're a tool and you want to find again your JDBC driver, even if it's already loaded, and still rewrite it to extract your method metrics, just have to tell the Instrumentation API what classes you want to load and or retransform. And of course, I mean, this looks super easy, but in practice, you'll get a class loader, you'll get the name of the class that's being loaded, you will maybe get a representation of the loaded class from the reflection API if the class already has been loaded. You'll get the protection domain, and most importantly, you will get the entire class file. The class file is just a byte array, basically a dump of the file that you have compiled with Javac. And then you are supposed to return a new Java byte array that represents a similar class, or hopefully a similar class, and then the one that was originally included with your changes. So first you have to decide if you want to transform a class, and then you have to transform it and then return the value. All right, yeah, I already said that. That's just highlighting here. So there's, however, some limitations. Unfortunately, if you retransform classes, you have to retain the structure of any class or method. So if you have a method m, you can't just go there, and you can go there and change the value it returns, right? You can change food to become bar. What you cannot do is that you add another method, for example, and execute this method from the first method. So you can, of course, replace the returning of bar by the returning of invoking another method, but you cannot add this other method. That is not allowed. And for a short period, you were allowed to add private static methods, which was with the intention to allow injecting lambda methods or lambda expressions, which internally are represented as private methods, more or less. But this was dropped again because it made the compiler too complicated, and sort of the compiler and the JVM, the JIT compiler, is already fairly complicated. So any benefit you can give to it by cropping small features like that one that aren't that important to the entire ecosystem are probably a good trade-off. And the entire point of it, of retaining the structure of any class, is with regards of that the JVM compiles classes and compiles methods or code the JIT compiler compiles code on the Java method level, starts inlining, and by restricting the allowed changes to just the shape of a method and not the shape of the class, you can make the de-optimization process much more efficient and much more simple. So and make basically runtime retransformation something that you can actually do in a production system without stalling all ongoing processes for way too long. And as a possible extension to lift this restriction, JEP 159, but to be quite honest, I don't think this will ever be merged. It's been a JEP that's been out for 7 years, and it's not useless. Of course, it's a good change, but it's a low priority change in a wide forest of many changes. There's a question if instrumentation retransform classes doesn't work sometimes. Well, instrumentation, the API has a method. It's called is retransformation allowed, which takes a class as an argument, and you can call this method and check. So what isn't allowed is to retransform lambda classes, so basically the runtime generated classes of the JVM to implement lambda expressions, and you cannot, of course, retransform primitives or arrays. But other than that, you can basically retransform anything. To the good and the bad. And in Mokito, for example, we allow to retransform more or less everything. But we suggest you don't, because retransforming system classes especially can cause a lot of issues, like transforming system.class or string.class. But of course, if you look into tooling, some like JRebel or these more invasive retransformation tools, they of course have to go deep down into the JVM, but they do it very differently on a C level, which allows you to do much more than on the Java level. But all in all, it's fairly universal, surprisingly. Yeah, I mentioned that this was taken away, so we are moving away from the dynamic code evolution VM rather than we are converging to it. Speaking of native agents, this is the simple Hello World version of a JNI agent, which you can also attach using agentlib, and which also you can attach using the virtual machine API dynamically. But personally, I'm not a big fan of writing C++ or C if I don't have to. So if you do like a very specialized project with very specialized engineers, it works quite nicely. But if you write like a big JNI agent and you have to maintain it, this will be a very costly, very easily failing endeavor. And if you can do it with a Java agent, then do it with a Java agent. I'd suggest, because I mean Java is successful because it's fairly safe and easy, and you get platform portability for free. Native agents, obviously, you have to compile for every chipset, for every operating system. So it will take much more to make it work, and it's much harder to test. But it gives you some opportunities that you don't have with Java, because simply since the Java agent is executed by the VM, it's basically by default on a bit higher level. So if you, for example, the Java agent, in order to be loaded, it needs to load certain objects like object or string. And once that's happened, as we just learned, you cannot change the shape of these objects anymore. So if you want to change the shape of object or string, then you are restrained to at least partially running a native agent. But normally that's not what you have to do or want to do. Yes, just some coloring. The Pine tool is actually a pretty cool presentation tool, but it doesn't accept my keyboard to navigate through slides, so I have to use the mouse, and I'm more lazy with the mouse. So you just get the colors afterwards. Just to wrap this up, this topic on how agents work, and then I'm already half through my presentation time-wise. How does this work? Well, Java class is compiled to a class file with Java C, and then there's a tool called Java P, which renders this class file as it is. It's bytecode and class file format. And of course, a .class file is binary, and Java P is just a implementation, so it's just a byte array. But the foo.java class, the foo.java file and the foo.class file, besides the change of representation from going from textual to binary, other than that, there's not much done by Java C. So you can still recognize fairly easily what everything is. And then if you parse the byte array, you can pretty easily find out, for example, if you want to replace a return value of a method, you just basically go in the class file, you at a certain index read the method table of the class, and then it lists at what byte offset every method is placed, and then there's some fixed length metadata at the beginning, and then it starts the bytecode, which is terminated after the length of the method is completed. And then, if you want to change something, you have to insert some bytes there. And it sounds very low level, elite programming whatsoever, but it's straightforward. If you're just a bit into it, it's the easiest programming you can do, because byte array is much more thankful to process for computer than a JSON file. So a JSON parser probably is harder to write than a bytecode parser in the end. And ASM is a pretty good tool that you can already use without having to do this yourself even. So in Mokito, for example, we use this approach to, once we started, you're using Mokito. Mokito starts up in JVM. And then we just use the virtual machine API to first we locate our own PID of the current process. And then we use the virtual machine API to attach an agent to ourselves. And doing that, we have an agent. And doing an agent, we can take a class that you want to mock, and then we can just replace the code in the method with the mocking logic. And then we use like a switch inside of the method where we say, if this particular instance is a mock, then execute bar as a mock. If this particular instance is not a mock, execute bar as it normally would be. So basically we do if, mock, else, normal. And that's all we can do with an agent. And suddenly we can mock final classes, because we can just inject our own logic into classes that already are loaded, and you don't have to subclass everything as you normally would. And suddenly we can mock not only final classes and so forth. We can mock static methods, because we can apply the same thing there. We can mock constructors, because now the mock code lives in the method, and the constructor is more or less just a method. And a static method, of course, is a method. And then, yeah, we can all do all that, right? Another example, as I mentioned, I worked at Instana for a while, and I wrote an APM tool on a contract there that they, of course, very much developed further since I left. But yeah, so what the idea was there also, like we find Java processes, as I mentioned before, and then we scan the whole operating system for PIDs that appear to be Java. We can poke a bit and see if they actually are Java processes. And once we find out, we just inject an agent into them. And the agent runs a bit, and then it can give feedback on what's maybe missing and so forth. And then you can just make the changes you need to extract the data you need. And then it just updates the agent inside of the JVM without even restarting it. So for example, you discover that this Java process uses a newer version of a library that you already support. And you can just give feedback, warning, there's a library that's very new and we don't know about it yet. So then we look at the library and then find out, all right, there's a new JDBC driver in this library that we want to support and extract metrics from. Then we just implement it, and then we push it, and then live, it's just played into the VM and you get metrics without even touching the process. So that's fairly neat. And you can, of course, extend this to inject yourself into Docker containers and so forth. So agents, if you use them as they are intended to, are very, very powerful, and you can do a lot of cool tooling on the JVM that you wouldn't be able to do on other platforms necessarily. .NET has a similar mechanism, but it's not as powerful by far, for example. And of course, then the tooling for .NET is worse than it is for Java as a consequence, just because of this one API. Yes, code instrumentation. And 40 minutes is just so short, so I have to start blasting through a bit, but I'll if you ever seen any of my presentations, you know that's how I operate. I brought a plan to match, and I choose wisely on the way. So typically I mentioned ASM. ASM is the way to go for code transformation, which is a visitation API. You create a reader based on the class file you get, and then you create a writer. And then by accepting a reader to the writer, the writer to the reader, you can basically play every segment of the class file back to the writer. So like the stacks parser, right? It's an event-driven parser. So then the writer will be notified. Here I found the class file version of the Java class file. Here I found a field. Here I found a method. Then you can visit the method and say, like, here I found an instruction to return. And then on every instruction, you can decide if you want to retain it, if you want to change it, or if you want to even throw it out. And you do that by wrapping the writer using a visitor. And then the visitor, you just override the methods that represent the steps in the processing that you are interested in, as it does with the stacks parser, right? You also say I override the callbacks on element on array method, and here you do just on the, they're unfortunately called more stupidly in ASM, so it's not always intuitive. And ASM has its quirks, but it's a very old library, and it has aged fairly well compared to many other libraries in this age. So can't complain too much. It's very solid too. So yeah, try it out. But it gets fairly quickly. There's the color again. Messy if you want to visit methods, and this is just to add 2 instructions to a method without even changing the method. And you can imagine, I'm not going to look into it much, how messy this can get if you write big trees of ASM. And if you want to see some really messed up ASM, then I recommend you that New Relic has recently published their agent open source, and that's all ASM. That's quite a bit of code to read through. And I admire that they managed to build all that on ASM, but I wouldn't. I consider myself a bytecode expert. I wouldn't want to maintain this. It's just too much, right? So and I've worked with bytecode, and the annoyance of working with ASM directly, not trying to discredit the library. It's a good library. It's just on a very high level, low level. While Byte Buddy, my library, tries to be on a low level and uses ASM to transform whatever you want to do to this lower level, right? And if you just can read this code without me even explaining it much, then I have succeeded, hopefully. So in order to write an agent, you just specify what types you want to instrument. In this case, you say like any type that has a super type that is named my target user type. And then for every type Byte Buddy discovers, it will check if the type itself is called my target user type, or any of its super classes or super interfaces is called like that, or if any of the super interfaces and the super classes are called like that, and so forth. So you don't have to worry about all this. Otherwise, you would have to visit every type, remember the result, and so forth. Here's just one readable line, and you can implement your own matches. Those are just for convenience. Let's say from Java 8 upwards, you can even use just lambda expressions because all these interfaces are functional. But I offered these shortcuts because Byte Buddy still supports Java 5 up to today, and I don't think this is going to change anytime soon, because tooling typically wants to support a broad range of software, and especially if you probably know that there's a lot of money in legacy systems. Actually, there's only money in legacy systems typically. So you don't want to scare off the big banks and insurances. If you want to make a bit of money, at least out of open source, then that's a good strategy. So that's my motivation, right? Right. So after specifying what classes to instrument, now you still have to specify how to instrument them. And the same as with this has supertype bit, you kind of just have to say, find me any method that matches anything, which is all methods, but not constructors. And then intercept this method by invoking the printle method on the out field of the system class. And with the argument hello world provided this method, invoke it, and then after you've done this, invoke the original instrumentation, which is called super method call, which is a bit clumsy. It should be called original, but it's implemented as if it was a super method call, and then that's what you just get. So you can focus on writing your own code, and it isn't much slower than ASM either, because it basically internally, once you've built this DSL, once you call install on, it translates all of this to more or less ASM, to like a enriched visitation chain, and just chases through all the data as if you would have written the ASM manually. So it's of course much more expensive to call this code once than it is to not call this code at all. But after that, it's fairly well streamlined. Yes, and I'll skip a bit over these. It's just about how things are implemented and why this wouldn't work with a dynamic agent. But for dynamic agents, Byte Buddy has a own API, which is called advice. And advice basically just means that you have methods, static methods in a class, and you annotate these methods with onMethodEnter or onMethodExit. what Byte Buddy will do then, it uses these classes as templates, translates them again into ASM code, basically, as if you had written ASM code to implement this line of code, and then appends it to the method by onMethodEnter, or suffixes it to the method on using onMethodExist. So let's say you have the user type again. Now you matched it, and it found any method. Here this in its method, and here you found it's called foo. Then Byte Buddy will take this template code and basically copy paste it into the method. So, and as I described before, and this is typically the big problem with using high-level bytecode APIs when implementing agents, is that you cannot change the structure, and a lot of tools need to change the structure to implement what they do. But with Advice, Byte Buddy offers you a way to just copy-paste basically template code in a very safe manner, so you can't mess up the bytecode, you don't get verify errors, and so forth. And then you can also tell this Byte Buddy disable class format changes, and which is an optimization, and then also enable retransformation. And take my word for it, copy paste this code into a program, declare dependency in Byte Buddy, run this as a Java agent, and it will work. It will just inject your hello world advice everywhere. And while this is of course not meaningful to print hello world, I already gave you the perspective on how this can be useful in many cases. So let's say that onMethodEnter takes the time, and the onMethodExit remembers this time and then prints the time a method call took, and you build your own metrics agent, and you're already done with it. Right. Exit instrumentation isn't that straightforward if you think of it, because the way it works is that Byte Buddy first copy pastes it to the beginning of the method, then it needs to back up the original code, and instead of returning immediately, it needs to store the return value intermediate value variable, then apply the exit advice, and then return from a method. And all these things, if you have multiple returns, it gets even more complicated, and Byte Buddy has to use goto instructions to jump around. But I'd say Byte Buddy is fairly widely used. I don't get any bug reports on it anymore, so it's so mature that I hope that it is good to go and can be used by anybody. Yes, I think I'll just jump a bit forward, giving my bad ability to estimate how long things take, and we'll just jump to class loading. Because when you work with Java agents, one of the more obnoxious topics in dealing with agents or Java processes in general is class loading, which is a very powerful mechanism that most programming languages don't even consider. And most programming languages just run one program, and all code is in the same namespace, if you say so. And Java has a two-dimensional namespace. Java has a namespace that is packages, of course, and class names. But Java has a namespace with class loaders. So a class foobar can exist in the same JVM twice on two class loaders if it's only loaded by two different ones. And typically class loaders are arranged in hierarchies that are strictly hierarchical, like the standard class loader hierarchy that comes with every JVM, where the system class loader loads everything on the class path, or now the module path if you use it. That has an extension class loader as its parent, which is more of a weird structure where in the JVM have a folder where you can put overrides into, like for JAXB and so forth, if you want to override the default implementations. And then you have the bootloader, which loads all Java system classes like object, string, and so forth. And if you load a class, then every class loader will first ask its parent if it loads it, if it knows the class, and return it if the parent knows it already. That way, technically, the JVM can not have multiple classes with the same name twice, because the parent will always load it first and then dominate the lower class loader in a way, even if it would knew how to load it. And the extension class loader was removed in Java 8 and replaced with this platform class loader in 9 and platform class loader, which now loads some modules like the SQL module and so forth, where the Oracle team thought that so as few classes as possible should be loaded on the bootloader, because the bootloader is special to the JVM. If you're on the bootloader, for example, you don't have any security checks applied to you in terms of accessing certain utilities like the unsafe, for example. And then you want to avoid that a lot of classes could have accidental access to it, because if there's like a security fault in the SQL module, if this fault was discovered while SQL module was on the bootloader, it would be more severe by definition than it would be if it is on a different class loader. So that's why this change was made, and the extension class loader wasn't used by anybody anyways. Yes, but people are very adventurous when it comes to using these technologies. So let's say a Tomcat class, Tomcat will create its own class loaders which load every web app, and then suddenly these classes loaders aren't parent first anymore, they are child first. Because if they know a class, they should override the system class loader's knowledge about it, and then they're selective about it, of course, and then you have OSGI, which does its own nonsense in terms of circular dependencies even, and so forth. And you can implement your class loader as you want it. It's a fairly open contract, and it says how you should do certain things, but not everybody respects these rules. And you can have clustering class loaders that aren't even part of the normal hierarchy and that you've never heard of. So if you're writing a Java agent, you have to take care of all of these possibilities. And the problem is that a Java agent is always loaded on the system class loader, always part of the class loader. No matter what you do, you can't change this. This is built into JVM. So if you wanted to instrument a class that's on the web app 3 class loader, for example, then your Java agent wouldn't even be able to see it. And if you write advice templates, you typically have to interact with other classes, because otherwise it doesn't make much sense, right? You write code against the APIs that the class offers, like the servlet API. But the servlet API, as I explain now, isn't necessarily loaded on your class loader, the system class loader. It might be loaded on the web app class loader, and then it's not visible. So, of course, I wouldn't tell you that if I haven't found a solution, and I would just keep it for myself. So let's say you have here the HTTP request and HTTP response on your advice, then those won't be available. And maybe you have your own tracing library that's loaded on the system class loader, then that's not available necessarily to the loader you're currently instrumenting. But, here's color again. But Byte Buddy fortunately offers you, instead of doing advice to, it offers you an opportunity to say just agent builder, transform for advice. Then you can include any class loader that you know about that contains classes you're interested in, like your tracing library. And then instead of referring to the advice class in its loaded state, you refer to it in its by its name. And then Byte Buddy will sew together the actual class loader that you're instrumenting and your class loader, and build a parallel hierarchy, and uses the so-called type pool to create a type description. Because internally, Byte Buddy doesn't use class files, or Java Reflection API, it uses type descriptions. And thanks to that, it can just emulate a hierarchy of types that wouldn't even be able to exist. And then you can still instrument code without even having to worry. So you still just write your compiled code in a provided scope in your build tool, and then you don't include the dependencies of your advice, but rather stitch them, let Byte Buddy stitch them together. Right, I have 1 minute and 20 seconds left, so I'll I complete my presentation with a nifty thing you should think about when writing agents in particularly. The JVM is built on heuristics when it optimizes, and especially garbage collection is very much based on it. So if an object dies young or old, is defined on its relative lifetime compared to other objects. So in a JVM that has object lifetimes like this, some object might be young, generationally collected, and some might end up in the tenured collection, which is much more expensive to collect. But if you add your agent and you have much shorter lifetimes than the actual application, then you promote possibly all of your applications objects to the tenured generation, which results in fairly changed garbage collection behavior, which is obviously nothing you want. So when you write agents, and if you write libraries for agents especially, you have to be very careful when you when you create objects, and to avoid it at most cost, and employ tools like object pooling in the worst case to not disturb garbage collecting behavior, because that can be very unforeseeable and very disturbing for users. And with these words, I clocked in my time by the second. My name is Rafael. You can find me on Twitter. You can find me on the web. You can find Byte Buddy on the web. And thank you so much for having me. And
Yeah.
thank you.
Thank you, Rafael. Can you hear me right now?
Great. Can you hear me still?
Yes, I can hear you.
Like, it's just lost cause. So say something nice sometime.
Okay, I will try. I will try
Right.
to ask the questions, but
I know what's
type
wrong.
in the chat. The chat.
Yeah. Oh yeah. See, I could have gone overtime.
Yep. And
Maybe I can.
let's see.
Yeah, because if there's no questions, then nobody can talk to me. Oh yeah, Byte Buddy on Java 9. Well, actually, yeah, there was a hefty adjustment, to be honest. The module system definitely has some challenges, and I did a talk on the module system, and the reason I'm so well acquainted with the module system is Byte Buddy. So the thing is that modules, as you know, import and export types, and if you instrument types, then if you instrument a type that's living in a module, then this type won't be able to, for example, read your generic tracing API because it doesn't import it, even if it's visible. So fortunately, the JVM offers an API to retransform module boundaries at runtime. However, that changes reflection and it breaks security, so people aren't very keen on these changes. So what people, and by people I say my customers by proxy via me, have started doing is that people inject classes into the base module of the JVM and dispatch via this base module. That's the most reliable option these days. By just saying I have a Java lang my tracing library, and you can of course do that. You can just open up your Java agent. You can break into every class and change them. If someone doesn't want to give you access to something, you just instrument the access in. If the security manager wants to stop you, you just instrument the security manager to not be in your way when you try to do certain things. If you can't call an API because of the people on the JVM team having hard-coded some check that only certain classes can call another class, then you just instrument the code that checks for these classes to include your class. So by definition, there's no stopping to it. It's the same with the attachment API that was also cropped a bit in Java 9. They added a check that you cannot attach from your own process to yourself, which is like the intention is to not make people rely on things they might want to change in the future. But it's, of course, I mean, took like 20 minutes to break this by just spawning a new Java process, and then you use this new Java process, which has a new PID, obviously, to attach back to your own Java process. And now Mokito runs again. It just takes like 4 seconds more to bootstrap Mokito. But even that we went around because the attachment API isn't it's not proprietary in this way, or it's not defined, but it still needs to be compatible between JVMs. So all you need to do is you have to send some bytes to some socket, some Linux socket, and answers, and you just poke around a bit until you have reverse engineered the API. And of course, you don't even have to do that because OpenJDK is open source. And now we just worked our way around it because, of course, the only way that a process can check who attaches to another process is by that other process telling you your PID. If I come from a Unix socket, nobody knows who I am. So I just can pretend I'm another process by implementing the API myself, and then JVM can't check that it's the same JVM anymore because it's too generic, right? So it was an annoyance in the beginning, but we found solutions, not only me, everybody who stumbled upon issues. And now it works quite smoothly. And I think actually the model system works quite nicely. It's not in the way in the wrong places, and it offers opportunities. Of course, adoption is still open, but yeah. How can we solve problems with memory using Java agents? Well, I wouldn't say that you can necessarily. If you have, I'm not sure how that's meant in detail, but so what you can do, of course, if you have a process that garbage collects too much because it allocates too much, you can theoretically So Byte Buddy has a build plugin too, where you can just annotate any method with the Byte Buddy cached. And then what Byte Buddy does, it stores the return value of the method in a field and never executes the method again, which is, of course, a measure thought for shortcutting expensive operations without having to write all this ugly if cached value is not null, return something else. But but all in all, typically that's something you want to address on another level. But of course, by avoiding recomputation, you can avoid allocations. Then you can do tricks, and often you have very clear bottlenecks in apps. So if you just find those, you can do a lot. Would I mention companies who use in production? Well, I mean, there's a list on the webpage. So Instana obviously uses it. They invested quite a lot. Elasticsearch also is a good supporter of the library. They helped a lot. Also in terms of maturing it, I'm trying to write more documentation, but I got another baby just 2 months ago, so now I'm not trying to write documentation, but to sleep in timely manners. Otherwise, I'm just too messed up to do anything. Byte Buddy is fairly widely used. AspectJ, Mokito, Hibernate, anybody really. Besides Spring, they're still resisting, but have open pull request to replace their internal port of CGlib. Not replace it, to accompany it by an option to use Byte Buddy. Because, of course, CGlib is a nice, slim tool. Byte Buddy has grown huge. And I've wanted to split the library up many times, but I don't see the benefit much, because Byte Buddy is very careful what classes it loads internally. So if you only use a certain segment of the library, you won't load many classes anyway. So, and the cost is quite high for a free tool to maintain such a big, and it makes it more confusing to use too. Although I hate this over modularization as well. Byte Buddy is zero dependency already. So you don't have this tail of dependencies you want to normally avoid with splitting up into modules. But thank you so much for joining me and us, and sorry for not hearing you. I'll buy a Windows computer just for these occasions.
All right. Thank you, Rafael, for joining us and sharing your knowledge with us. And we are breaking for a longer break. So thanks everybody for joining, and see you soon.